So this worksheet is going to help us understand why the chain rule works the way it works. Okay, we're going to be finding derivatives using the chain rule. That's going to be our new differentiation rule. But in order to find derivatives of composite functions, we need to revisit composite functions. All right, so if you went ahead and did this worksheet because you can kind of understand what's going on, wonderful. Just kind of fast forward, go to the end, and look at all the answers filled in and see how you did. Okay, but in the meantime, notice that we're given the following composite functions. Okay, composite. That means they're pretty complicated. It's a function within a function. Number one is a composite function. It says that if y is equal to f of g of x, then what are the f and g functions? Well, we really want to pay attention to the order here. G is inside of f. So if g is inside of f, g is the inside function. Okay, we can see that inside the parentheses here, we have 3x plus 5. So that's our g function. So what we're doing is we're decomposing this function right here. All right, so what do I do with 3x plus 5 to create y equals? By putting g inside of f. Well, f must be the power function x to the 6th. All right, so if we were to perform this action right here, based on our background from our previous courses, if I were to put g inside of x, that means just actually wipe out x and replace this x with 3x plus 5, okay, it would build this equation right here. All right, look at number 2. All right, we want to find g and f so that g is inside of f. Okay, you think of order of operations as well. Okay, well, 2x is the inside function. The outside function is sine of x. So if I were to compose this function right here, create it by following this order, by putting 2x inside of this x, I would create 2. Problem 2. All right, so we're decomposing actually. All right, so looking at this function right here, again, f of g of x, g is the inside function, so 5x minus 3, the linear function, gets placed inside of the function tangent of x. All right, so we just wanted to kind of revisit and think about some of the words that we used in our previous courses. All right, the inside function here is what's underneath the radical, and so we're asked to find g, which is the inside function, 4x minus 2, and we're going to put that inside of a square root of x, actually wipe out x, replace it with this, and it composes problem number 4. So we're actually just breaking it down, decomposing it. So all the g functions are inside functions, and here all the f functions are outside functions, our outer functions. Okay, and g is not always the inside function, it's just the way that we have y defined here. Okay, so let's look at 5, 6, and 7. It gets a little more complicated because we're dealing with more than 2 functions. We're dealing with 3. Okay, looking at 5, okay, we want to find h, g, and f. H is the innermost function, and the best way to think about the inside function is if you were to find a value, if you knew what x was, what's the first computation that you would do? That's the innermost function. Well, the most inner function is you would take your x, whatever it is, and add 4. After you add 4 to x, you're going to take that and you're going to square it. So our next function is x squared. And then we're going to actually perform the last operation, which is the cosine of x. All right, so just think about it. If I were to put x plus 4 inside of this x right here, wipe out this x, it creates this part of the problem. And then if I were to take that I built and put it in for this x, I would compose this problem number 5. All right, let's decompose number 6. Now, notice the difference between 6 and 5. The square is not on the trig function in problem 5. The power is not on cosine, but here the power 3 is on the trig function cotangent. So how we handle this is going to be quite different than how we did 5. The outermost function on 5 is cosine, but that's not going to be the case for number 6. Cotangent is not the outside function, okay? At least the outermost function. Okay. On 6 and 7, I'm going to suggest that what you do is anytime you see a power on a trig function, rewrite it. meaning pull the power off of the trig function and put it on the outside of a bracket or a parenthesis. Because that's what it means. Okay, the last thing you're going to do is cube. That's going to be your outermost function. The last thing that you would do computation-wise is cube something. So x cubed is going to be the outermost function. All right. All right, so let's work our way out of this problem right here. The innermost function, if I knew what x is, would be to multiply x times 4. Once I did that, then I would find the cotangent at 4x. So I'll put a cotangent x. And then after I find the cotangent, I'm going to take that answer and I'm going to cube it. So the outermost function is x cubed. All right, number 7, the first thing you want to identify is, yeah, I have a power. I have a power on a trig function, so let me rewrite it. Okay, and again, compare and contrast 6 and 7 with how it's different than 5. All right, I'm going to pull off the power of 4 and put it on the outside of this bracket. That's going to be the last computation you perform, is taking something to the 4th power. All right, so paying attention to the order, h is the innermost function. So the first thing I'm going to do is 3x minus 5. Then I'll find the tangent at that value, tangent of x, and then I'll take that answer and I'll take it to the 4th power. All right, so we just actually decomposed some composite functions, and that's going to help us understand the chain rule because we have to have the words, the language of inner function, outer function, etc. All right. All right, these other notes we'll do at some other time together.